Hello, students. Unfortunately, I cannot be there today. I had a little bit of an issue at my house, so I'm doing the second most exciting thing besides math, which is fixing the broken heat in my house. Anyway, the good news is I made this awesome video that you can watch to learn about how to do absolute value. So maybe you guys have seen absolute value before. Here's what it looks like. It's represented by these cool looking vertical bars like this. So let's say you wanted to take the absolute value of -6. The absolute value of -6 is 6. Well, why is that? Some people like to say that absolute value is the distance from 0, which is not the worst thing I've ever heard in my life. I mean, it kind of makes sense. Like if you were to look at the number -6 on a number line, like let's say here's 0, and then 1, 2, 3, 4, 5, 6, and then -1, 2, 3, 4, 5, 6. So you have -6 over here. You might say, well, how far is it from 0? Well, I mean, you don't have to be a genius to calculate that it's 1, 2, 3, 4, 5, 6 spaces away from 0. So I guess in some sense, it's okay to say that the absolute value is a number's distance from 0. But I'm going to tell you what absolute value really means. Absolute value is actually what we learned earlier as a piecewise function. What does that mean? It means it's defined in two parts depending on what the input is. So like, if x is greater than 0, you just leave it alone. Whenever x is greater than or equal to 0. 0 doesn't really matter because the absolute value of 0 is 0. But you make it -x whenever x is less than 0. What? What does this mean? Well, let's take a look at our example we did up here, the absolute value of -6. Well, ignore that, that's an email. The absolute value of -6 is less than 0, right? -6 is less than 0. So how do we evaluate the absolute value of -x? We do of -6, we do -6, right? You take the input and multiply it by a negative. -6 is +6. Okay, so some people say absolute value means if it's positive, you leave it alone. If it's negative, you make it positive. That's pretty good too. But what I'm trying to show you is that the way it's actually defined in the real world of mathematics is if it's positive, you leave it alone. If it's negative, you multiply it by -1, right? So if the input was 5, you would just leave it alone. The output's 5. If the input was -5, because -5 is negative, you do -5, and -5 is +5. So that's how the absolute value function is defined. If you want to think of it as the distance from 0 or just make it positive, that's fine, but this is the technical mathematical definition. But anyway, let's do a couple sample problems, and I think you'll see it's pretty darn easy. Okay, -7. Well, it's negative, so you just make it positive. Or according to the technical mathematical definition, if it's negative, you multiply it by -1. Either way, you get 7. -2, the absolute value of -2 is +2. Now, positive numbers are pretty easy. I mean, they're all pretty easy, but absolute value of 6 is 6, and the absolute value of 0 is 0. So it's pretty darn easy. You'll notice that absolute value can never be negative. In fact, the lowest absolute value you could ever have is 0. The absolute value of 0 is 0. The absolute value of anything else is always going to be positive. Okay, so now we know what absolute value is. Let's see what it would look like if we tried to graph an absolute value function. So let's consider the simplest absolute value function, which is f of x equals absolute value of x. Okay, so we want to evaluate f of -7 and f of 4. Remember, we're using this function, which is really just the absolute value of x. So f of -7, it's negative. you make it positive. The absolute value of negative 7 is 7. The absolute value of 4, it's positive, so you just leave it alone, is 4. What is the minimum value of the function on this interval? I assume they're talking about this interval here, but either way, the lowest output you can get from an absolute value function is 0. Right? I kind of just said that. The absolute value of 0 is 0. The absolute value of any other number is positive. Oh, we skipped over part B, but not a big deal. The absolute value of negative 3 is 3. The absolute value of negative 2 is 2. And so on. Excuse me, and so forth. Okay, sorry for abruptly cutting off there, but I had to sneeze. All right, I skipped over part B, but it's real easy. The absolute value, we're using this function here, which is just the absolute value of x. So whatever the input is, you just take the absolute value of it. The absolute value of negative 3 is 3. The absolute value of negative 2 is 2. I mean, you can see pretty easy. If it's positive, you leave it alone. If it's negative, you make it positive. And graph the function. This should be extremely quick. Well, you don't know how long it takes me to do things, but okay. Let's graph these points here. So the first point, remember, your f of x is basically your y. So our first point here is negative 3, 3. So on the x-axis, we go negative 3, 3, like that. Negative 2, 2, like that. Negative 1, 1. And you're going to see it has this cool, like, V shape. And I don't know if they want me to connect these points, but let's just say we do connect those points. So this is generally what the shape of the absolute value graph looks like. It's always going to be a V shape. There's a couple things you can do to it to like slide it around, but it's always going to be that V shape. And over what domain interval is f of x increasing? So increasing means when the graph is going up from left to right. So it looks like it's increasing here. It's going up from starting at 0 and ending at 3. So we could say it's increasing on the interval x equals, or x is in 0 to 3. This is the symbol for like x is contained within, in case you were wondering. Okay, so this is what I'm going to ask you guys to do on your own. I'm going to help you get started a little bit, and then I'm going to send you off on your own to finish filling in this table and then graphing it. So maybe I'll do like the first 3 or 4 points for you, and then you guys are going to finish it up on your own. Okay, so we're graphing this function here that says g of x equals absolute value of x minus 4 plus 7. And so I kind of made like 3 columns in this table. So the first column is going to be our inputs. The second column is going to be a place for us to just write out the calculation. And then the last column is going to be your output or your y. So you're going to have an x, for every input, you're going to have exactly 1 output. We're going to have points, and then we can graph them. Okay, so let's start with plugging in negative 3. We're going to put in a negative 3 wherever we see x. So this is going to be absolute value of negative 3 minus 4 plus 7. Okay, well, negative 3 minus 4 is negative 7, and the absolute value of negative 7 is positive 7. So everything inside here becomes positive 7, right? That's negative 7, and the absolute value of it is 7. So really what we have is 7 plus 7, which is 14. So the output is 14. So we have our first point, negative 3, 14, which I wonder if we're even going to fit negative 3, 14 on the graph. Maybe not. I can go back and change this graph to make it a little bit better. Okay, the next one is we're plugging in negative 2. So we're going to do the absolute value of negative 2 minus 4 plus 7. And again, let's do the inside the absolute value first. Negative 2 minus 4 is negative 6. Then we take the absolute value of that, which is 6. And 6 plus 7 is 13. And okay, we have -1. Now we're going to plug in -1. -1 minus 4 is -5. We take the absolute value of it because it's inside the absolute value bars. The absolute value of -5 is 5, and 5 plus 7 is 12. And then this is the last one I'm going to do for you guys, but we're going to plug in 0. 0 minus 4 is -4. The absolute value of -4 is 4, and 4 plus 7 is 11. Now let's go ahead and graph these, but actually before I graph them, I'm just going to tidy up that graph a little bit so it's a little bit easier to see, to fit all the points on there. Okay, so I made the graph a little bit better so we can fit numbers like 11, 12, 13, and 14 on it. Okay, so our first point we're going to graph, the x value is -3, 14. So I don't know, maybe we'll write out the point. It's the point -3, 14. Okay, so our x value is -1, 2, 3. And then we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm pretty sure that's right there. If I messed it up, I'm sure someone will tell me. The next point, the input is -2, the output is 13. So that's the point -2, 13, which, assuming the first one is right there. The next point is -1, 12. Which is right there. And then the last point that I did was 0, 11. Let me just make sure this is right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Look at that. Perfect. Okay, so where do we go from here? Well, your job is I'm going to put up a class kick. You're going to finish filling in the table, and you're going to finish graphing this equation. If you have any questions, you can message me, but quite frankly, I'm probably not going to get back to them today, so we will look over this tomorrow, but give it a shot. All right, guys, look for the class kick assignment, finish filling out this table, finish graphing it, and I will see you guys tomorrow.